Let us look at proposition number 18 of Works of Archimedes, specifically book 1 of On the Sphere and Cylinder. The proposition says, any solid rhombus consisting of isosceles cones is equal to the cone which has its base equal to the surface of one of the cones composing the rhombus and its height equal to the perpendicular drawn from the apex of the second cone to one side of the first cone. So let's see what this means. Given a rhombus OABD with two cones OAB and DAB, both have a common base, that is a circle with diameter AB. Draw DE perpendicular to OB. So which means we will have to extend OB to join with DE. Let FHK be another cone such that the base, that is a circle HK, is equal to the surface of the cone OAB and height is equal to this perpendicular line that we have drawn from the apex of the second cone, that is DE, and we join FH, FK and HK. The proposition is saying is that the cones on rhombus OADB is equal to cone FHK. That means the sum of the surfaces of these two cones will be equal to the surface of the cone FHK. So let's see how we can prove this. Construct a third cone element with base Mn equal to the base of the cone OAB and height LP equal to OD. OD is the line joining the apices of these two cones. Now, let's set up a proportionality. Since LP is equal to OD, let's set up a proportionality of these two with CD, a common magnitude or the same magnitude. LP is to CD. LP is to CD as OD is to CD. Now, OD is to CD. OD is to CD is equal to the cones on rhombus OADB is to cone DAB, and LP is to CD is equal to cone element is to cone DAB, which implies that cones on rhombus OADB is equal to the cone element. Now, AB is equal to MN because we constructed this cone element with base Mn equal to the base of the cone OAB and surface OAB equal to the base of the cone FHK. So base of cone FHK is to base of cone element is equal to the surface of OAB is to base of cone OAB. Here surface OAB is equal to the base of cone FHK and base of cone element is equal to base of cone OAB. So base of cone FHK is to base of cone element is equal to OB is to BC. OB is what? OB is one of the generators of this cone OAB, and BC is the radius. Base of cone FHK is to base of cone element is equal to OD is to DE. Why? Because triangle ODE is similar to triangle BDE. Base of cone FHK is to base of cone element is equal to LP is to FG. OD is equal to LP and DE is equal to FG. Now here in this proportionality, we have in the cones FHK and LMN, bases are reciprocally proportional to their heights, which means cone FHK is equal to cone LMN. But cone LMN is equal to cones on rhombus OAD. So which means cones on rhombus OADB is equal to cone FHK, which is what we had to prove. So that is proposition number 18 of works of Archimedes, specifically book 1 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.